All right, we are ready to discuss one nice problem involving vector projection. So the problem is, well, we want to find the distance between this point P to the line y equals 2x. Well, by definition, the distance between this point and this line is the smallest distance between this P and any point on this line. So the distance is going to be the length of this guy. So we are after this length. There are many ways to find such a distance, and we want to use vector projection to find this distance. Okay, well, let me start with taking vector OP. Vector OP is this guy, and I'd like to call this vector B. So we have vector B, and then we want to use vector projection. Well, if you project the vector B down onto this straight line, we will get vector, this guy, but this doesn't give you the distance. So instead, well, you can use this projection and then Pythagorean theorem and so on, but let us use different projection. So instead of projecting B onto this straight line, we want to project this B onto somewhere else. Okay, so let vector B is OP. So we have vector 4, 3. Good. And then let me pick any point to have vector A. So pick any point, pick a point, say Q on the line. And then let OQ be our vector A. Instead of projecting B onto A, we want to use orthogonal complement of this vector. So if you think of orthogonal complement looks like this. So we have orthogonal complement here. So if you project B onto this orthogonal complement, something nice happens. So you can think of this direction, and you are projecting B onto this direction, which will give you this vector. This is pros B onto A pop. We are interested in this vector because once you figure out this magnitude, this will give you the distance. Okay, so consider vector projection B onto A pop. Here, orthogonal complement is, remember, for this orthogonal complement, you swap the coordinate and then change the sign. So to specify this vector, we need to pick some point Q. Now that it has slope 2, you can pick 1, 2, 2, 4, and so on. 1, 2. So orthogonal complement of this is, well, you swap the components and change the sign of first guy. So let us use this orthogonal complement and take projection, vector projection of A onto this orthogonal complement. Okay, the distance is just a magnitude of this guy, comp of B onto A. Let me repeat the formula for this guy. Well, For this formula, what we need is dot product over magnitude of A once, because the remaining part is just a unit vector. So magnitude of this guy is completely, just this. Okay, so we are ready to calculate. So A dot B over A. But in this case, we are taking projection of B onto the orthogonal complement. So we need to take orthogonal complement like this. Okay, orthogonal complement is here, and we have vector B. We have everything to calculate this. All right, so A perp dot product 4, 3 over magnitude of this guy. Okay. Dot product is -8 plus 3, and the magnitude is square root 5. And so -5 over square root 5. You may want to rationalize to have this value. But remember, this is supposed to be positive number. So you take absolute value symbol. So the distance is square root 5. There are many other ways to calculate this distance. Again, you can project B onto A and then use Pythagorean theorem, because magnitude of this guy squared is sum of square of magnitude plus and square of this magnitude. Or in this solution, we are using different vector. Instead of using A, we used orthogonal complement, and you took vector projection of B onto this orthogonal complement, and once you calculate magnitude, you will get the distance, the desired distance between this point and the line.